So we're going to do the even problems now since we did all the odd ones yesterday. So just the second half of the review today. So looking at number 2, we want to solve, and first step is to isolate our radical. So what should we do? Subtract 5. What's 14 minus 5? 9. So 9 square root 9p. How do we get rid of that square root on the 9p? Nope. We got to square it. So we do the opposite of whatever it is. So get rid of the square root by squaring it. So these cancel. And if we square the right side, we have to remember to square the left side too. What is 9 to the second power? 81. So 81 is equal to 9p. And then what should we do to solve for p? Divide by 9. So what's 81 divided by 9? So 9 is equal to p. And that's our answer. Any questions on this one? Number 4. What do we need to do first? Divide 2. So it cancels out on the left. We have x plus 2 to the power of 3 over 4. And that's equal to 16 divided by 2, which is 8. What should we do next? The reciprocal. So whatever our exponent is up here, we want to flip it. So 4 over 3. So if we raise the left side to the power of 4 over 3, we have to do the same thing on the right side. Multiplying by the reciprocal cancels it out. So then we're just left with whatever's in our parentheses. And then that's equal to 8 to the power of 4 over 3. So we need to figure out what 8 to the power of 4 over 3 is. So let's do that on the side. What is our index? Our index is 3. 8 goes on the inside, 4 goes up top. What are our factors of 8? 4 and 2. And our factors of 4? 2 and 2. And we have to circle groups of how many? Groups of 3. So we take out a 2, but we still have that 4 as our exponent. So 2 to the 4th power is like 2 times 2 times 2 times 2. What's 2 times 2 times 2 times 2? 16. So we have x plus 2 is equal to 16. What should we do next? Subtract 2. So what's x equal to? 14. Awesome. Good job, guys. So I put a little note here from yesterday. If the question asks you, does this graph have exponential growth or decay, we can tell just by looking at what the equation is. So if the number that has the exponent is less than 1, it's decay. If it's greater than 1, it's growth. So let's look at number 6. So the number that has the exponent, we're looking here. Is this growth or decay? Growth. It's greater than 1. 3 is greater than 1, so it is growth. So we know it's growth without even graphing it. But next thing we should do is graph it, because that's what this problem tells us to. So we're going to plug in values for x, get values for y. What should we plug in for x? -1. We'll plug in -1 first. We can list all the ones we'll plug in. So -1, 0, 1, and 2. Let's plug in -1 first. We have 2 times 3 to the power of -1. What does the power of -1 do to that 3? Turns it into a fraction. Awesome. So we have 2 times 1 over 3. The exponent turns it into a fraction. If it's already a fraction, it just flips the fraction. So 2 times 1 over 3 would be 2 over 3. so y is 2 over 3. So our point is going to be -1, 2 over 3. So we go to our graph, we're going to go to the left one and up 2/3. So to the left one, up 2/3 would be about here. Not quite to 1 yet. Next we're going to plug in 0. So we have 2 times 3 to the power of 0. What's 3 to the power of 0? Not 0. 1. So this is 2 times 1. Anything to the power of 0 is 1. Make sure you know that for the quiz. So 2 times 1 is what? 2. So we plugged in 0 and got 2. So we stay at 0 and go up to 2. Put our point there. Next we plug in 1. So 2 times 3 to the power of 1. What's 2 times 3 to the power of 1? 6. Just 2 times 3, so that is 6. 6. So we plugged in 1 and got 6. So we go to our graph, we're going to go to the right one and up 6. And lastly, we plug in 2, so we have 2 times 3 to the power of 2. What's 3 to the power of 2? 9. So this is 2 times 9. And what's 2 times 9? 18. So we plugged in 2 and got 18. So we go to our graph. We're going to go to the right 2 and up to 18. And this is our graph. So again, here we see we have exponential growth going on. So we know we graphed it right. So on the quiz, make sure you plug in the 4 numbers. You need to plug in 4. So you need to have 4 points on your graph. And I need to see your work. Don't just put the line. Got to see your work for plugging in numbers and getting your points. Any questions on this page? All right, next page. So just a little reminder from yesterday. We use this formula for our word problems. Unless it says compounded continuously, then we use our PERT formula. And anytime you have a percent, you have to change it to a decimal. And then just make sure you know how to put it in your calculator. Let's take a look at number 8. Your starting salary at a new company is $40,000 and it is increased by 3% each year. What will your salary be in 5 years, round to the nearest dollar? So it doesn't say compounded continuously, so we need to find our A, our R, and our T. So we're using the first formula. What's our A, our starting amount? 40,000. What's our rate? 0.03. Awesome. 3%, we change it to a decimal, so it would be 0.03. And then what's our T? 5. It says 5 years. So we plug everything in. A is equal to 40,000 times 1 plus, it's plus because it says increase, but just be careful if it said decrease, it would be 1 minus 0.03 to the power of 5. What do we need to do first when we put this into our calculator? What'd you say? Not the exponent. Before we do that. Parentheses. PEMDAS. P comes first. Parentheses. So we want to do the parentheses. So A is equal to 40,000 times 1 plus 0.03 would be 1.03 to the power of 5. Segi, what do we do next? The exponent. So 40,000, 1.03 to the power of 5, so 1.03. I click that exponent button, x raised to the y, and then 5. So I get 1.159 dot dot dot. Keep it in your calculator so you have the most exact answer possible. What's the last thing we need to do? Multiply. So we multiply that long decimal that's already in our calculator by 40,000. And we get 46,370. It says round to the nearest dollar, so instead of 0.9, we can just round up to 70.1. I mean 71, not point, because it's the nearest dollar. If you guys are off by a couple dollars here, not a problem. It just means that you rounded somewhere. But if you're off by like $100, then that would be a problem. So if you had 400 or 46,370, that's totally fine. No problem. But if you were off by a lot, then that would be a problem. So just make sure that you are putting it in the calculator right. Make sure this number is what you get after you do the exponent. Keep it in your calculator and multiply by 40,000. Any questions here? All right, we did 9 together in class, so let's look at 10. An initial deposit of 5,000 is made into a savings account that compounds 6.2 interest annually. How much is the account at the end of 5 years? Does it say compounded continuously? No. So we're still using that formula from above. So A, R, and T is what we need to find. So what's our starting amount? 5,000. What's our rate? 0.062. And what's our time? 5 years, so 5. So we plug it into our formula. A is equal to 5,000 times 1. We're increasing here, so plus 0.062 raised to the power of 5. What should we do first? Parentheses. So 5,000 times 1 plus 0.06, which will be 1.062 to the power of 5. What do we do next? The exponent. So 1.062, click that exponent button, and then 5, and then equals. So this would be 1.3508 dot dot dot. Keep it in your calculator and multiply it by 5,000. So A is equal to, what do we get? $6,754.49. Again, if you're off by a couple cents, that's totally fine. But if you're off by like $20, not fine. Alright, so that is our answer. Let's go to the next. So number 12. Cindy opened a savings account and deposited $100 as principal. The account earns 4% interest compounded continuously. What is the balance after 1 year? So, we need our APERT formula. So P, my pencil just is not cooperating today. Okay, P, R, and T. So our principal is what? $100. What's our rate? 0.04. So 0.04. And what's our time? 1. So we plug that into our APERT formula. We have A is equal to P times E to the power of R times T. What should we do first? The parentheses up top. So 0.04 times 1 is just 0.04. What should we do next? The exponent on the E. So when you put this into the calculator, be careful because depending on your calculator, you can put it in the opposite way as like a kind of shortcut. So if you put 0.04 and then you click that E with the exponent button, that'll give you the answer. So you can do it this way. So 0.04 and then E to the power of X, and we get 1.0408 ... So again, make sure you know how to put this in the calculator. Practice putting them in the calculator over the weekend. What do we do next? Multiply by 100. What do we get? 104.08. Perfect.